All right, welcome back, everybody. We are going to interpret and use some regression lines. So we've got the situation where we've got some lab rats and their weights for the first 25 weeks after their birth, a scatter plot of the response variable weight and the explanatory variable the time since birth shows a fairly strong positive linear relationship, which is good. That means regression applies. It needs to be relatively strong and linear. The regression equation y hat equals 100 plus 40x models the data fairly well. So question number one, predict the rat's weight at 16 weeks old. What we're going to do for predictions is change the regression equation just a little bit so that we are including our explanatory and response variable. So essentially, instead of writing y hat, we are going to write out the variable that we're predicting. We are predicting the rat's weight. So the predicted weight, I'm going to write weight and then kind of draw a little hat on top of it. That's actually not a little hat, but you get the point. So this hat means predicted. The predicted weight is equal to 100 plus 40 times the explanatory variable, which is time since birth, or I'm just going to say time. Okay, so that is the regression equation that we're going to be using. So hey, the predicted weight is equal to 100 plus 40 times. So hey, the explanatory variable that we're calculating our prediction from is 16 weeks. So I'll just put 16 in there. And so our predicted weight is going to be, just looks terrible, but hey, so our predicted weight is going to be, 100 plus 40 times 16. So that gives us 740. 740. Fantastic. So we predict that the rat is going to weigh 740 grams. So let's make that a statement. Remember, adding context and interpreting values is always very important in AP statistics. So we predict the rat will weigh. We predict the rat will weigh 740 grams after a time of 16 weeks. So hey, in that interpretation statement, we are including the units and some kind of like context to our situation. So I included the grams and the weeks for time and weight. Okay. So calculate and interpret the residual if the rat actually weighed 700 grams at 16 weeks old. So for residuals, we're able to follow this pretty simple formula. A residual is equal to the actual value of the response variable minus whatever it was that we predicted. So the residual in this case is going to be, so since he actually weighed 700 grams, it'll be 700 minus this predicted value, which we already did in question number one. At 16 weeks, we're expecting the rat, or predicting that the rat is going to weigh 740 grams. So our residual is negative 40. Essentially, to interpret this, that means he didn't weigh as much as we expected. We expected him, or we predicted that he was going to weigh 740 grams, but he only weighed 700 grams. So for our interpretation here, the rat weighs 40 grams. The rat weighs 40 grams less than what was predicted. That's really the important part of the residual. So hey, residuals are essentially error. How far off was our prediction? from what actually happened. And then was that actual amount, was it less than or was it more than what was predicted? That's really it. Question number 3, should you use this line to predict the rat's weight at 2 years old? So 2 years old, that is going to be around 104 weeks. 104 weeks. So that's an issue because the data that was given to us used the first 25 weeks after its birth. Maybe that's because a rat is essentially like full grown after 25 weeks. So, hey, what's the rat going to weigh at 2 years old? So let's just figure it out. So the predicted weight for the rat, the predicted weight is equal to, right, 100 plus 40 times 104. What do we expect here? What are we predicting? What's the predicted weight for a rat after 2 years at his second birthday? 100 plus 40 times 104. So we are predicting his weight to be 4,260 grams. 4,260 grams. We're predicting the weight to be 4,260 grams. How many grams are in a pound? I think it's possibly 400 something. 454. Hey, so in 1 pound, just to kind of highlight the issue here, in 1 pound, we have 454 grams. So, hey, for our rat, 4,260 divided by 454, might just be easier to interpret this way. That's like 9.4. So this rat would be 9.4 pounds. That is like a small dog, you know? That is pretty unreasonable. I don't think there's any lab rats running around that are 9.4 pounds. That'd be seriously frightening and concerning. So should you use this line to predict this rat's weight at 2 years old? Definitely not. The answer to this question is certainly no. No, because 2 years old, 104 weeks. 104 weeks or 2 years, 104 weeks is far outside the given X interval. So we had data ranging from, its first week after birth up to its 25th week after birth. 104 weeks is far outside of that interval. And remember this term is known as extrapolation. That is known as extrapolation. You do not want to extrapolate data. And the further off that you go in whatever X direction, the worse your prediction is going to be. So I'm assuming if we were to weigh this particular rat after 2 years, it's going to be nowhere close to 9.4 pounds or 4,260 grams. All right, fantastic. So always be aware, extrapolation is certainly a bad thing. You don't want to do it. For interpreting the slope of the regression line, so you know that the format goes like this. The predicted y hat is equal to a plus bx. That's the form for a regression line. And a is the y-intercept, b is the slope. So if we look back up to what was given to us up here, the slope is always the coefficient of the explanatory variable. So the coefficient here of 40, that is the literal value of the slope. So b equals 40. And hey, so to interpret this value, we know that the slope is 40, but to interpret it, we need to add some context. Such a big deal, adding context. For adding context to this situation, it is how much does the predicted response variable change if we increase the explanatory variable by 1 unit? So on average, it's a good way to start this off. On average, we expect the rat's weight on average, we expect the rat's weight to, hey, so since our slope is positive, we're expecting that the weight is going to be increasing. Had the slope been negative, we would expect it to decrease. So hey, on average, we expect the rat's weight to increase by 40 grams for each additional week after birth. So I just wanted to really add context, trying to add and include everything that this problem was telling us to. So on average, we expect the rat's weight to increase by 40 grams for each additional week after birth. So hey, at 26 weeks, if I were to increase this, right, at 26 weeks, I would expect if I was to increase this by 1, I would expect the weight to go up by 40 grams. That's always how you will interpret the slope. Always use 1 unit for the explanatory variable, and how does that correspond to a change in your predicted value, in your response variable. Okay, so the last question, number 5, does the value of the y-intercept have meaning in this context, and explain why? So yeah, the y-intercept is the a value from this equation. So we know that the y-intercept, the a value is equal to 100. So the y-intercept is where the explanatory variable is equal to 0. So essentially I don't even do that, at time equals 0 weeks, we expect the rat to weigh, we expect the rat to weigh 100 grams. So does the value of this y-intercept, does it have meaning? Does it make sense? Is it reasonable to include this point? And I think the answer to this one would be yes, because time equals 0 weeks. That would just be the first recorded weight of our rat. And so essentially, does the value of the y-intercept have meaning in this context? Yes, because this is the rat's weight. This is the rat's weight at birth. So hey, in the example that I'm going to give you in the live session, right, in our live Zoom meeting, is the number of strikeouts that the pitcher has, and we had the y-intercept of that situation as a negative amount, which didn't make sense. A pitcher can't go into the game and get a negative amount of strikeouts. So always be on the lookout for that. Sometimes the y-intercept is not going to have meaning, even though it still helps you with your regression line. So that's going to do it then. That's how you interpret and use regression lines. And that's what you're going to be doing in your assignment for this day. So hey, thank you for watching, guys. Have a great day. Bye-bye.